Okay, we're going to do the derivatives of exponential functions. Remember, the derivative is just e to the u times u prime. So if you're going to do anything and be stuck, at least know you're going to rewrite e to the whatever you have. So I have the derivative of e to the 2x is e to the 2x times u prime, which is 2. Derivative of e to the radical x is e to the radical x times the derivative of radical x, which is 1/2 x to the negative 1/2. If you want to clean this all up, the negative 1/2 goes here with the radical x, e to the radical x over 2 radical x. And that can bother you if you want to rationalize that. It doesn't bother me. Derivative e to the x minus 4. So the derivative of the exponent is just 1. So these are the same. Now we get to product rule, and so the derivative of the first times the second plus the derivative of the second times the first. A lot of times you will see this factored out. You can add those two as well. If you're trying to find zeros, you need to have it in a factored form, because eventually we're going to set the derivative equal to 0. So if you were doing this, this would be x ln x plus 1 over x. And then you could solve, find that 0, that 0, that 0. But we're not doing that yet, so don't simplify. Derivative of the first times the second plus the derivative of the second times the first. Again, look, we have repeating stuff. So we have an x squared and an e to the x that we can take out of everything. Leaves you with 3 plus x. So again, that makes it nice to solve for later. You get -3 there and be good to go. So practice factoring it a little bit. It'll help you out later on. Okay, chain rule. D outer times d inner. D outer 3 e to the negative t plus e to the t squared times d inner, which is negative e to the negative t for that, plus e to the t. Now you got to decide, are these the same thing? And they're not really, because that's negative e to the negative t. So we're really talking about a reverse order. These aren't going to be able to be combined. You can stop right there. Use your log rule, u prime over u. So u prime be the derivative of the numerator, which is 2e to the 2x over u. That's it. Follow your log rules. It just happened to have an exponential inside of it. For this one, it looks like you may want to do a quotient rule. Some of you will change this and do a product rule. It doesn't matter. Or change it and do a power rule. This is a good one to chain rule it on. So if you rewrite this, now you can do -2 e to the x plus e to the negative x to the negative 2 times the derivative of the inside, which is e to the x minus e to the negative x. Because that's the derivative here. If you want to combine, you can. Not really any good reason to unless you're writing it as a fraction. So we'll show it. Can't have too many of those fundamentals. So if you had to solve it, you'd want it to be in this form. And that is the problems from the book on derivatives of logs.